So in this example, cyclist takes 25.1 seconds to cover that displacement of 115 meters east from D1 to D2. Question A, calculate the average velocity. So we're being asked to find VAV as the vector, keyword velocity instead of speed. We've been given the time of 25.1 seconds, and we've been given the displacement of 115 meters to the east. We can just go ahead, plug this into the equation. We don't need to include the units or the direction in the question. We can simply reattach them at the end. Dividing this out, we'll need 3 sig figs, as both of our measurements have 3 sig figs to them. We get 4.58. Velocity is measured in meters per second. And since the displacement was to the east, the velocity will also be to the east. Question B, if the cyclist maintains the same average velocity for 1 hour, what is their total displacement? So we know that they're going to keep that same average velocity, 4.58 meters per second to the east. And now they're going for 1 hour. However, when dealing with calculations, we need to have standard units, and standard unit of time is seconds, and we already know that 1 hour is 3,600 seconds. 1 hour was given with 3 sig figs. Those 2 trailing zeros are significant, so our 3,600 seconds should also have 3 sig figs. We'll do that to keep that. The question is asking, what is the total displacement? So what is delta D? Same equation. This time we know VAV. We do not know delta D, and we do know delta T. Again, as with the speed version of this equation, we'll cross multiply. We'll round it to 3 sig figs, and we get 16,500. This is displacement, which is measured in meters. And as it is a vector, we do need a direction. Continuing moving to the east would allow this displacement to be to the east as well. I'm just going to clean this off to do question C, and I've put the question down again along with the image that's on that slide. If the cyclist turns around at D2 and travels to position D3, which is 565 meters west, in 72.5 seconds, what's the average velocity? So the cyclist now is not at D2. He is turned around, he is at D3, which is somewhere over here to the west. This is at 565 meters west. What is the average velocity? This is one of the confusing pieces between distance and displacement. The cyclist has gone from D1 all the way to D2 and then back to D3. So if we were determining the distance, and distance is a scalar, we would need to add those two distances together. But since we are talking about displacement, we don't. Displacement is defined as the distance And I know I shouldn't be using distance to define this, but it is the distance from the start point to the end point. Start point is at D1. End point is at D3. The cyclist has done whatever he has done in the middle, but in the end, the basic motion was going from point D1 to point D3. The displacement between those 2 points, well, how far is it to go from 338 meters west to 565? That is 227 meters. And the cyclist has gone to the west. So we now know his displacement, 227 meters west. We know the time it took, 72.5 seconds. What is the average velocity? That's what we calculate out. Same equation. Substituting in 227 meters west for displacement, 72.5 seconds for time. Going to 3 sig figs would give us 3.13 meters per second. And the direction would be to the west. Even though for some of this trip the cyclist did move to the east, overall his velocity was towards the west because he ended up west of where he began.